Hello and welcome all of you. This is a concept discussion series by NEBAs where we are going to discuss the contribution of Indian scientists. And this discussion will help you for your prelims as well as mains. Now from the mains perspective, the contribution of Indian scientists is a major portion in GS3 paper. So this can come as a question. So it includes scientists from the ancient era, medieval era, and modern era. We have covered the ancient and medieval aspects as a separate series. You can check that out. Now, when it comes to the modern discoveries, we have inculcated the mains as well as prelims aspect. For example, in this video, we are going to discuss about two scientists. One is Srinivasa Ramanujan, the one whom you see here. The second is C.V. Raman. Now, when we talk about C.V. Raman, we also have to talk about Raman effect. We also have to talk about Raman spectroscopy. Now, these can be technological questions from science and technology portion in prelims. So we'll explain the concept as well in this video. So the way we have designed it, it will benefit you for your mains preparation and prelims preparation. So we are taking it forward as a series where we will discuss two people per video. In this video, we are going to discuss Srinivasa Ramanujan Iyengar, arguably the most famous scientist and mathematician from India. Second, we are going to discuss C.V. Raman. Now, coming to Srinivasa Ramanujan, he was born in Tamil Nadu. Even C.V. Raman was born in Tamil Nadu. He is from Erode and he lived from 1887 to 1920. So, if you observe his time period, he lived just for a time span of 32 years. And in these 32 years, he has come up with 3,900 mathematical results. So, results means the proofs that he come up with for postulations. So, mathematics works on postulations and proofs. So his discoveries are technical in nature. From a UPSC perspective, that's not very relevant for us. So we'll just talk about what he has come up with and what are his achievements. His domain is mathematics. In this short span of time, in the span of 32 years, he has come up with 3,900 results. Now, there are three path-breaking contributions in his 3,900 results. These three will be enough for you to act as a value addition in mains. First, you can write about Ramanujan prime, a number he came up with when he did the research on Berthold's postulation. You don't have to write that details, just write about Ramanujan prime. Second, the partition formula. Third, Ramanujan theta function. Either one of which you can write as a value addition for your mains. Now, what were the achievements of Srinivasa Ramanujan? This is very important. Now, he was the youngest fellow of the Royal Society. The Royal Society is in Britain. This is a community of scientists. It has renowned scientists like Isaac Newton, Albert Einstein in it. So he was the youngest fellow of the Royal Society and only the second Indian member. The first member was a shipbuilder, not Kursaji. He is not a very famous person. I will bring him up in this series. He is the first person from India. He was into the field of marine engineering. He's from Gujarat. So we'll discuss that later. Now, with respect to Srinivasa Ramanujan, he was the second Indian member. He was only the second Indian member during that time. And he was the youngest. Second, he was the first Indian to be elected as a fellow of Trinity College, Cambridge. Now, this can be seen as his biggest achievements. Now, this is one movie. Now, the actor in Slumdog Millionaire, he has acted as Srinivasa Ramanujan in this movie. The movie is named The Man Who Knew Infinity. That's why I said he's one of the most famous Indian scientists. Now here, one more information I would like to add is Srinivasa Ramanujan's association with Cambridge University started with this person, G.H. Hardy. He started a mail association. He started sending mails and associating with him. Once G.H. Hardy realized that Srinivasa Ramanujan's results and postulations had great potential, he made for an arrangement for traveling to Cambridge. Then Srinivasa Ramanujan was in Cambridge. He continued his research there. He came up with a lot of research, and then he came back to India and he died at the age of 32. Now I'm just adding all these for you to remember it in context rather than to just mug up the facts. So the time period, the context, the story, the achievements, and the major findings. These things have to be kept in mind. Now let's move to C.V. Raman. Now, C.V. Raman again is from Tamil Nadu, but his field of contribution or his field of research is in physics, and his time period is 1888 to 1971. The first thing that you should remember when we talk about Srinivasa Ramanujan is Raman effect. Now, what is Raman effect? In theoretical words, I can sum it up as inelastic scattering of photons. I'll explain it. Now, photon means light, the particles that makes up light. Now, how do we see light? We see light when light comes and hits an object. For example, when you're seeing this on your screen, light is coming up, it is hitting on this object and it is getting reflected back. So you are watching it in your eyes. This light is reflected back by this object. It hits your retina. Then it goes to your brain. It gets converted into a signal and you're observing this. So light is getting scattered by objects. We can call these objects matter. Everything is made up of matter. Your mobile phone, your device, your hands, your cells, everything is made up of matter. Even light is made up of matter. The matter that makes up light is called photon. The matter that you see around you are made up of things like carbon. Now, when photon hits a matter, this matter will scatter the photon. This scattering can be elastic and inelastic. Elastic scattering means, now keep that much in mind, I'll just introduce two more concepts to you. Photons or light or electromagnetic waves have two properties. One is wavelength, second is frequency. Now waves travel like this, right? The length of this wave is the wavelength. Frequency in a particular band of time, how much time it goes up and down, that's the frequency. Now you can just understand it in a very basic sense. So just keep in mind that light is a wave and this wave has two properties, wavelength and frequency. Now, when a wave gets reflected by a matter, there will be change to its frequency and wavelength. When the frequency and wavelength remains the same as it comes, so what is coming is incident, what is going back is reflection. So the frequency and wavelength, if it's same as it is in incidence and reflection, then it can be called as elastic scattering. If it's different, it can be called as inelastic scattering. Elastic scattering is a concept that was given by Lord Rayleigh. And we call such scattering Rayleigh scattering. This is also a UPSC concept. Inelastic scattering is called as Raman scattering or Raman effect. So it's just about the inelastic scattering of objects. Now, how is this relevant? For example, take the case of a cell in your body and take the case of a rock. The way this cell is going to reflect light and the way this rock is going to reflect light will be different. So depending on the difference in the reflection or refraction, you can study the properties of this matter. You can study the properties of this cell. You can study the properties of this rock. This mechanism is called Raman spectroscopy. Based on Raman effect or Raman scattering, we have a method called Raman spectroscopy. This is a widely used method. Now, Raman spectroscopy is a very efficient method. It is non-contact because you are using light. For example, you want to study a virus. You don't have to touch that. You can use light. The data is of high quality because light properties are used. It has extreme precision. Then it can be used to examine small particles, something like a cell, something that is very microscopic. So for all these things, Raman spectroscopy is very efficient. Now, it is applied in wide variety of fields. UPSC always has a habit of asking the applications. Now, Raman spectroscopy has applications in every field. Life sciences, here I include everything. DNA, RNA, virus, everything can be analyzed using Raman spectroscopy. Art and heritage, for example, when you take a painting, for example, go to the Ajanta caves. When you're examining the Ajanta paintings, you can use Raman spectroscopy to understand what kind of material that were used. what kind of paintings were used, what kind of paints were used. All these things can be understood. Next up, energy sector. To make up solar cells, you can use Raman spectroscopy to understand the different materials, how different materials react to light, which material absorbs more light. So that material can be used for solar panels. That is one example that I have given you. In the energy sector, it has applications. In the pharma sector, it has applications for detecting virus, for conducting new research, to come up with new diagnosis. So these are the applications. The applications can be wide, can be in a wide range because of the very concept. So I hope the concept is clear to you. That is more important here. It's about the inelastic scattering of lights. I've told you light is made up of photons, and matter makes up everything around you. Matter reflects photons, and when photons are reflected, the wavelength and frequency get changed. Now the achievements of C.V. Raman. Here the title is C.V. Raman. The achievements of C.V. Raman. For this discovery, he got the 1930 Nobel Prize, and he was the first Asian, not even the first Indian, the first Asian, and the first non-white to receive a Nobel Prize in any branch of science. So even before this, Tagore got Nobel Prize for Gitanjali. That was in the field of literature. This is in the field of science. That should be clear. Now Raman also has other achievements. He has made studies in percussions. That means instruments like tabla. So he was not just interested in the waves of light, he was also interested in the waves of sound. That's why he had done research on this. And this is one of the first scientific study on this field. Now this is another paper that Raman has written, The Color of Sea. Now this is where it all started. After this only he came up with Raman scattering. So when he was traveling, he observed the color of the Mediterranean Sea. And he came up with the finding that the molecules of water is made up of molecules, right? H2O. The molecules of water scatters light. And because of the scattering of light by the molecules of water, the blue color is created. It was developed by his followers after that, his students. You just have to keep in mind that Color of Sea is a paper written by C.V. Raman, and this is the finding. And the base of all this is the Raman effect. I think that concept need not be explained again, that is clear. Now keep in mind the Rayleigh scattering as well. Rayleigh scattering about elastic scattering of light. Now light can be scattered elastically and inelastically. If 99% of light is scattered elastically, 1% can be inelastically scattered. And from this 1% you can get the properties. The color of the sky is predicted or understood using Rayleigh scattering. Alright. So that's it. We'll come up with yet another scientist and yet another concept in another video. Thank you for listening.